Science View, where we cover the latest advances in Japanese science and technology. I'm your navigator, Tomoko Kimura, and this week's Science Watcher is astronaut Naoko Yamazaki.
Hi, I'm happy to be here today.
Here is today's lineup. Today on The Leading Edge, we have Moonrush, the frontier of lunar development. Countries around the world are proactively taking steps towards lunar development. One of the things that triggered the moon rush was the Japanese lunar orbiter Kaguya. Today we'll take a look at the satellite's trail and the challenges that civilian teams are facing in their attempt to develop the moon. And on J Innovators, Michelle?
I'll be introducing a Takumi or innovator who developed products with high deodorizing properties using steel manufacturing techniques. The Takumi set its sights on a photocatalyst, which reacts to light to give them antibacterial and deodorizing properties. We went to see the Takumi and the product that he developed, which has the potential to be used in schools and hospitals to prevent diseases from being transmitted.
So let's begin with today's Science News Watch. Ms. Yamazaki?
The National Institute of Informatics has been designing an artificial intelligence with the goal of making it intelligent enough to pass the University of Tokyo's entrance exam, which is considered to be the hardest in Japan.
The artificial intelligence that is aspiring to pass the University of Tokyo's entrance exam is known as TORobo. It was developed by a research team led by Noriko Arai, a professor at the National Institute of Informatics. This year's mock exam was TORobo's second attempt. Its scores were not enough to achieve its goal of entering the University of Tokyo, but the results indicated that it had an 80% probability of passing the entrance exams of over 470 universities, including 4 national and public universities. It scored above average in Japanese, English, world history, and math. Its English score was particularly improved. It had a higher comprehension level of English conversation and was able to understand the context of a word by studying the sentence flow. This was accomplished by incorporating a language recognition technology that is used in smartphones and other devices. However, it had a hard time understanding pictures and graphs or comprehending long sentences.
Professor Arai said, developing an artificial intelligence is extremely difficult, and we are pleased to have achieved the scholastic ability of the average high school student in their final year. By revealing the possibilities and limitations of artificial intelligence, I hope to help Japan utilize it wisely. By applying this technology, it may be possible to develop an AI that is capable of small talk and companionship.
And now for the leading edge. Today's theme is about the front lines of lunar development. Ms. Yamazaki, in recent years, we've been seeing an increase in programs to develop the moon.
Yes, you're right. After the United States Apollo 17 project in 1972, lunar development hit a stagnant spell. But recently, the US, Russia, and even emerging countries like China and India have launched rockets towards the moon and are working on development plans.
So, what caused this renewed interest in lunar development?
The main reason is that different countries began taking notice of the resources that are buried in the moon. It's been learned that the moon has helium-3, which is eyed as next-generation energy, and water, which will be needed for people to live on the moon, among other resources. And one reason lunar resources began gaining global interest was because of the achievements of a lunar orbiting satellite that Japan developed called Kaguya.
Let's see what Kaguya's lunar mission involved. Take a look at this.
Japan's lunar orbiting satellite Kaguya was launched in 2007. It was a high-tech machine equipped with 14 measurement instruments. It was the first full-fledged lunar exploration project since the Apollo program. The mission assigned to Kaguya was to learn as much about the moon as possible. One of its biggest achievements was recording the world's first images of the moon's surface using a high-definition camera. The incredibly clear images showed the moon as it had never been seen before. A flat terrain stretches out as far as the eye can see. This area is called a lunar mare, which means a lunar sea. It's the part of the moon that looks like a dark spot when viewed from Earth. Kaguya also conducted a detailed study of the far side of the moon. In sharp contrast with the near side of the moon, the far side is covered with rugged terrain. The elevation difference reaches a couple thousand meters, and it's literally the Grand Canyon of the moon. This valuable footage was taken by Kaguya towards the end of its 380,000-kilometer journey. This piece has been titled Earthrise. Kaguya orbited the moon 6,500 times over a period of 1 year and a half. It collected data from over 10 million observation points. The accurate topographic map of the moon that it created was particularly groundbreaking. This was accomplished with a terrain camera. Two cameras pointed in different directions would take a picture of a certain spot from both the front and back. Then a three-dimensional map was made by overlaying the two images. When compared with the image on the left, which was taken by a conventional probe, the difference is clear. Kaguya's terrain camera captured surface objects that are just 10 meters in diameter. The 3D data is realistic and makes you feel like you can reach out and feel the rough surface of the moon. It's the world's first topographic map of the entire moon. Kaguya provided an accurate look at the moon's shape. It showed us that rather than being a smooth sphere, it has a complex shape. Of the topographic data that Kaguya gathered, certain areas attracted the most global attention. They were the North Pole and South Pole. The polar regions of the moon were regarded as vital areas for lunar development. Within the craters at the South Pole are spots that never receive sunlight. They're called permanent shadows. It's believed that the temperature within these places is a constant minus 160 degrees. Kaguya detected numerous permanent shadows near the South Pole. The many discoveries that Kaguya made ignited the desire for lunar development in countries around the world.
Let's take another look at the permanent shadows that Kaguya discovered. This is a diagram of the permanent shadows based on data collected by Kaguya. The black parts are permanent shadows. They sort of resemble holes. 2 years after Kaguya's exploration, the US sent an observation satellite called L-Cross to the moon to study the permanent shadows further, and it discovered large amounts of water.
Yes, I remember the news.
The discovery was aided by Kaguya's images. And the further analysis of the data that Kaguya gathered indicated that there could be long tunnels or lava tubes underground.
Lava tubes?
Yes, they were formed during lava flows long ago. Unlike the surface of the moon, which has drastic temperature changes, the lava tubes are believed to maintain a steady temperature. Because it has a stable environment and can also provide protection from radiation and meteorites, the lava tubes are considered the best locations for lunar bases.
I see.
These discoveries bring the dream of living on the moon much closer.
So, to sum it up, Kaguya's extensive study of the moon led to the discovery of resources, and it's heightening the possibility of living on the moon someday. That's quite an achievement.
Yes, by the way, did you know that there is a very interesting prize competition going on related to lunar development? It's organized by a private foundation in the US, but a Japanese researcher is taking part in the race. Here's a video shows more about it. Take a look.
A desert spreads out at the base of Hawaii's Mount Mauna Kea. Preparations for a certain experiment are underway. They will be test driving a lunar exploration rover called Moonraker. Developer Kazuya Yoshida is currently participating in a prize competition. It was organized by a private foundation in the US. Private corporations are competing to see who can build the best lunar exploration rover. The exploration rover must complete two main missions. First, the rover must be sent to the moon and run for over 500 meters. Next, it must send high-definition images back to Earth. The first team to complete both objectives will win a prize of $20 million. And there are extra bonuses. An additional $4 million can be won by filming the Apollo equipment that remains on the moon. And then there's a $2 million prize for the rover that survives 2 weeks of the moon's severely cold nights. The prize money comes to a grand total of $30 million. Over 23 teams from around the world enter the competition and are working to complete the various missions. The key lies in overcoming the moon's unique environment. For example, the surface of the moon is covered by extremely fine sand. It crumbles easily and gave past astronauts a hard time. The lunar rover also had a difficult time with it. The desert that Yoshida and his team are conducting the experiment in has sand similar to that on the moon and was used as a training site during the Apollo program. The experiment has begun. The wheels are big and are designed to keep the rover from sinking into the sand with its own weight. The bits on the edges allow it to grip the sand firmly and move forward. On the moon, the rover must be able to assess the situation and proceed on its own. The camera mounted on top gives it a 360-degree view, allowing it to confirm its surroundings as it moves. Here are images that the camera filmed. As you can see, it provides a clear view of the area around it. Climbing slopes is the biggest challenge. Although it occasionally faltered, this experiment proved that the rover is capable of climbing inclines of up to 15 degrees.
I'm very confident about the rover. The experiment we held here today boosted my confidence even further. But the rover isn't the only important thing. We need to prepare a rocket equipped with a spacecraft for getting it to the moon. Running the rover is the last step. We need to consider the whole process, and there are still a lot of issues to work out.
The challenge has only just begun. Yoshida and his team will continue to develop an experiment with the new rover.
So, a privately owned foundation is organizing a prize race for lunar exploration. This is exciting.
Yes, the time limit for this race is December 31st, 2015. There are many teams from around the world, like the US, Europe, and other countries, as well as one team from Japan.
You know, because so much goes into launching a probe, landing it on the moon, and using it for exploration missions, I used to think that it was too big of an undertaking for private corporations. But that's not the case now, and the moon seems more accessible and familiar.
Yes, there is a corporation in Japan with plans to make a hotel in space, and they are currently working on some incredible lunar utilization plans as well.
A hotel in outer space. That sounds like something from a sci-fi movie.
This video will explain more about the plan. Please take a look.
This is a major construction company in Tokyo. The company is looking forward to the space age and working on the concept of a space hotel. And they came up with a revolutionary idea for utilizing the moon.
This is a lunar solar power generator, the lunar ring.
The idea is to use the moon itself as a generator. First, the whole moon will be ringed by solar panels. The energy that is generated through solar power will be converted into microwaves and transmitted to Earth. It will be received offshore and then converted into electrical power. The company estimates that a 400-kilometer wide ring of solar panels will be enough to meet all of the Earth's energy needs. And what's more, they suggest using lunar sand to construct the solar panels. Lunar sand contains a large amount of silicon, which can easily be formed into solar panels.
If we can use the moon to generate electricity, any country that can see the moon can receive energy from it, which would be great for countries with a shortage of energy. The goal is for it to benefit mankind as a whole.
The company is pushing forward with research and hopes to begin construction in 2035.
That is an immense project. It's literally out of this world. And if achieved, it will be a new energy source that replaces both nuclear and natural energy.
In addition to the generators, the company has proposed plans to build a lunar base and is working daily to achieve this goal.
I see. And could you tell us about Japan's upcoming plans for lunar development?
Yes, JAXA, the Japan Aerospace Exploration Agency, is currently working to send Kaguya's successor to the moon. And while Kaguya only orbited the moon, the new explorer will land and send out a rover for observation missions. It will also use seismic waves that occur there to study the inner structure. I expect the challenges towards the moon to pick up pace as time goes on.
city, Fukuoka Prefecture. The city has historically been an area that flourished in the steel and iron industry and making precision machines. Hi, I'm Michelle. I'm in Kitakyushu City, Fukuoka Prefecture. The city is known for its active steel industry. The Takumi, or innovator I'm going to introduce to you today, has used this steel industry technology in a unique way to create a new product. Let's go and find out. The company that I visited mainly makes rollers that are used in metal processing. Hello, I'm Michelle Yamamoto.
Hello, I'm Atsuo Yamamoto. Welcome.
I'm glad to be here. Here is today's Takumi, Atsuo Yamamoto. He immediately showed us to a place that uses his product.
It's over here.
Here? This is a toilet.
That's right. Please go in.
Okay. I heard that your company was in the steel business. Is your newly developed product somewhere in this toilet?
First of all, I want you to see if you can smell that distinct toilet odor.
No, it doesn't smell at all. There's usually an unpleasant odor.
The secret lies in the floor under your feet.
Here is the product that the Takumi developed. These tiles contain a photocatalyst that reacts to light. I took a reading of the toilet's odor level. The meter read 52. This is roughly half the amount found in public toilets. The photocatalyst effectively assisted in decomposing the odor.
This is the material.
It's so soft and very light. The identity of the photocatalyst is this titanium oxide powder. When the titanium oxide comes into contact with light, it reacts to the oxygen and water in the air and produces active oxygen. It's this active oxygen that decomposes odor sources like ammonia. On top of that, it also kills E. coli bacteria and influenza viruses. How did a company in the steel industry get involved in the development of antibacterial products?
I didn't feel that there was any more room in the steel and iron industry to grow in Japan. I felt that the environmental business was promising and wanted to break into it to help boost the company's performance as a whole.
But the development of the tiles involved much trial and error. To fix the photocatalyst agent onto the tiles, they first tried mixing it with glue. However, this method reduced the density of the agent and did not perform as well. It also peeled off easily. So the Takumi set its sights on thermal spraying, which is widely used in steel factories. In thermal spraying, the coating agent is melted and then blown onto metal or other surfaces at a high speed. But the technique could not be used without making changes. This is because heating the photocatalyst to 2000 degrees would cause it to lose its photocatalytic function. So the Takumi tried reducing the temperature to about 800 degrees, which is half the usual temperature. But this caused the spraying force to become too weak, and the photocatalyst peeled off easily. It took the Takumi 10 years to develop a thermal spraying device specifically for the photocatalyst agent. Here it is. By adjusting the fuel gas and other factors, he found a way to maintain the spraying force even at a temperature of around 800 degrees. As a result, the photocatalyst remained intact, adhered well to the tile surface, and no longer peeled off easily. We
we asked him how he plans to expand the product further.
病院関係ですね。
The product can help prevent hospital infections. So I want to introduce it to hospitals, schools, and other places.
Do you have any big hopes or dreams?
I want the product to be used in outer space. For example, in space stations, where conditions aren't the best.
So, this is it. Well, to tell you the truth, odor is a problem in a space station, so this will be useful. We conventionally use air filters that need to be replaced periodically, but this technology would be maintenance-free.
Yes, so someday it might be used in space, and I hope to see them used around us as well.
The product that we saw today was introduced to a university's pig house and is being tested to see whether it's effective in preventing foot and mouth disease. In the laboratory test, it successfully repelled 99% of disease germs and viruses. Also, the company is currently developing a giant deodorizing device for managing the exhaust air and odors that are emitted from factories and sewage treatment plants. The device will greatly reduce costs.
I'm surprised that still manufacturing technology was used to develop life science products. They use a technique from a different field to create a completely new product. It showed how creativity and flexibility play a part in Japan's manufacturing.
Thank you very much, Michelle. Ms. Yamazaki, how would you wrap up today's program?
Today, we covered the current state of lunar development and its future potential. Right now, countries around the world are racing to develop space technology, and the competition will only heat up as time goes by. I look forward to seeing what role Japan will play in lunar development and what new achievements will be accomplished.
Thank you, Ms. Yamazaki. And that's all for Science View. See you next time.